Welcome to Evolution in Controls. I'm your host, Tim Wilson. Thank you for joining us. The need for moving heavy loads or achieving high-speed linear motion has always been a challenge, regardless of industry or application. Engineers have been tireless in their attempts to develop linear movement systems that can meet the demanding requirements, and creating those systems is far from easy. It involves intricate engineering, extensive development time, and the potential for costly mistakes. So does that mean that a solution is out of reach? What if there was a way to streamline the process and eliminate the hassle of independently designing a linear motion system? What if manufacturers could easily select their application specs and receive custom blueprints in a matter of days? It may sound too good to be true, but Morel Group is turning this concept into a reality. Morel Group is preparing to launch the new Morel Linear Module, a solution created specifically for heavy loads and high speeds. Here today with us to talk about Morel Linear Modules is Mr. Tom Rinke, Advanced Engineering Manager and leader of the Motioneer Group here at Morel. Tom, thank you for joining us.
Thanks, Tim. Thanks for having me.
No problem. Why don't we start by you telling us a little bit about yourself and your background?
Okay, so I'm a mechanical engineer. I've been with Morel now for almost 3 years. My background has been in automotive, mostly test and measurement. I've been doing this work for 35 plus years since I was a teenager. I got my feet wet early, and I've been in, like I said, test and measurement, automation. Got in the middle of my career in machine design and build.
Have you been involved in these type of systems, these linear module systems or linear motion systems before?
Yeah. We use them for a lot of test and measurement systems back when I was in that part of the industry. And then when I get into machine design and build, obviously specifying motors and drives and gearboxes and linear rail and ball screws and belt assemblies, and so all those types of technologies.
Well, our viewers may be familiar with them, but for those that aren't, define what a linear module is.
Okay, so to me, a linear module is kind of a collection of products that support and guide a payload. So
what are the basic elements?
So some of the basic elements are basically just the structure of the assembly. It could be an extrusion, it could be a weldment, it could be some base structure. And then a guide system could be ball rail, roller rail, any type of linear guide, track rollers. Okay. And then the assembly that pushes and pulls. So it could be a belt, could be ball screw, could be acme screw, could be rack and pinion. So that's the part of the assembly that moves the payload.
Are there characteristics or specifications that help you select whether it's a cam guide or a roller rail or a belt drive?
There are definitely, based on the requirements, so it could be the level of precision required for basically guiding the payload. Could be precision of the motion, repeatability, accuracy, those kind of things. Those kind of guide the direction on what type of technology you want to use.
So it's not just the speed or the weight of those loads?
No, not necessarily.
Okay, all right. Well, linear modules, what you described, and those components or parts of the assembly, they've been around a long time. What makes this Morel linear module, what makes this new or technologically advanced?
So really from our standpoint, a customer brings a request into us for something. Hey, we want to move this in this manner. And we go right to our standard product offering. We sell Bosch Rexroth linear modules of a number of shapes and sizes and capacities. And basically from that, we go into that product selection. And what we found through that interaction with our customers is that sometimes there's things that are outside that product offering, really large payloads, really long travels, maybe speeds that don't match up with our current product offering.
So the customer wants to carry something that's heavier than what Bosch Rexroth has
in
a product designed for.
Correct. And traditionally what we would do is sell them the components to build their own system. So maybe a larger ball or roller rail, maybe a larger rack and pinion system, and then they take that and engineer with those components in mind.
And the designing process where we give them those products, that's a challenge for some machine manufacturers?
Correct. Yeah, they look to us as the technology experts. So the way it works today, typically they'll give us those parameters. Hey, I want to move this load in this orientation at this speed with this level of precision in this environment. we collect that and we kind of collaborate with them to pick the right product mix.
These customers that we're talking about, or these loads, give me some examples of what we're talking about. Is it a box of chocolates? Is it water?
Could be anything. Pick a payload. Could be a robot. Could be a collaborative robot. Could be a standard industrial robot.
So the robot would be mounted on a tray or on a panel, and you're moving that whole robot.
Correct.
6 meters?
Correct, yeah. In an industry, that's called a robot transporter, or robot, basically a robot transport unit, RTU.
RTU.
Typically floor mounted, could be wall mounted, could be inverted, but in characteristics, it's very similar to a
upside down, hanging on a wall?
Upside down, yep. Could be in a lot of different ways.
Does that drive the mechanisms that are involved?
In some cases, yes. Yeah, in some cases, especially for the guide systems, unless it's a cobot, which is a relatively small robot. You get into some of the larger systems, the payloads go way up because you're carrying the robot and you're carrying the payload of the robot. So those systems are quite large. And that's one very specific instance of that technology being packaged and engineered that way.
Okay, all right. So we talked a little bit about the customer. Before, we would give the customer individual components and they design it. Here, we're doing some of that engineering.
Right.
Is that the role that the Motioneers are playing in this?
So today, the Motioneer team is really part of the sales organization. So we facilitate those conversations with customers. We're actually taking on a slightly separate engineering effort, which our Motioneer team will collaborate with. So they're kind of like internally the voice of the customer. So they're going to help guide us on what path we take, what types of technologies are most called for. Because beyond the current product offering, there's a whole range of things that we could do. And really what we want to do is understand from our customer standpoint, what do they want?
Do you have some basic specs of what we're talking about? What's the maximum weight that we're looking at designing for, or the maximum speed, or maybe the length of travel?
Yeah, we don't. Well, if you talk about RTUs, in particular, the payloads go up quite large. I mean, we go up into size 65 rail, which is quite large. In rack and pinions, the same types of systems. Kind of hard to categorize because you can do different combinations of components. We can carry really, really large loads. I mean, 120 plus thousand pounds if we really wanted to, from an engineering standpoint. That's way over here on the extreme end, right? So, but when you start talking about what we see out there today, it's travels in excess of 3 to 5 plus meters, maybe longer. Sometimes these applications get into 30 meters long. And then speeds could be anywhere from 1 to 3 to 5 meters a second. And again, all the engineering that goes into that as things scale up. So we don't really have a very narrow focus today on different types of products that we're going to really engineer today. Right now, it's kind of like, here's a line, here's current product offering, and then there's all of this out here that we could do.
So what are the deliverables that Marel provides? Is it, like I said in my opening, is it a set of blueprints? Is it a set of blueprints and a box of materials? Is Marel a manufacturer? Are they delivering something that's fully built and the customer takes it?
I think that could be one possible outcome.
The last one?
Today, the way it works, yes. Today, the way it works, we work with a customer and we collaborate, and it's typically a kit or a box of parts that have already been engineered. Like, here's a rail system, here's some geometry around that. Here's a rack and pinion system and how that works. All the pieces to do it. I think where it will go is we'll start to have a structure behind that. And what that looks like isn't really fixed today, but then you would buy that as an assembly. And you could pair up a Rexroth motor and a gearbox assembly, and then take that as you would take a current Rexroth module.
Does that help us maintain parallelism between the rails?
There are some engineering specifications that are required to do that properly. So that would be
flatness,
part of
parallel.
Yep, exactly. Yeah, types of preload on the guide systems. All those performance, those things that impact the performance of the overall system.
Okay, so how far along in this process are we? Do we have customers that we've delivered this to? Is it really just a field of dreams at this point? Where are we at?
It's somewhere in between there. We haven't been working on it all
You're
that
going to build
long.
it and they will come?
A little bit. We're still in the early stages today. We've built a couple of prototype early release systems. You can kind of see them up on the screen here: ball screw assembly and a rack and pinion assembly.
And that looks like a finished product that we would sell to somebody.
Correct. We've built that, and again, it's scalable to some extent.
So that could potentially go for 6 meters long.
Yeah. And we've engineered the ball screw assembly might be a little shorter than that, but the rack and pinion for sure. Okay. Scalable to longer travels, and we know what the performance is. We know what that system's capable of today. So that's kind of the pre-engineering exercise that we've gone through for these types of systems.
Okay. Well, we're coming to the end of our time. What does the future look like? Today we're at the start. What does it look like 5 years from now?
So I think we'll have in 5 years a little narrower focus. Today it's a pretty wide net. Like I said earlier, we have the current product offering, and then there's all of this that we could do out there. And I think what's going to happen is we're going to engineer some of the basic constraints of the systems, and then as we move forward in time, customers are going to see these different things and go, yep, here's kind of a product offering that fits a large majority of our needs. And we're going to start to be able to hone in on and optimize those solutions. So I think it's going to narrow. We may not design that 120,000 pound system out here. Maybe we will, but I think we'll be able to focus on, where we are from our current product offering and what the rest of the roadmap looks like.
So you're essentially saying it's going to go from limited use of a custom system to broad adoption of a more standard system.
Correct. And we'll have some categories around it. I think my goal in the end of it is that, people recognize it. It's not where they come in and say, hey, I need a custom. I'd rather use the term pre-engineered and have some sort of a model around it where they can walk in and go, hey, I need a TKZ module. And we know, and the industry knows what a TKZ is and what its capability is and where it fits in the product offering. That's kind of my goal for that.
In the next year or maybe 2 years, when you get some of these applications out in the field, would you be willing to come back and talk to us? Maybe we'll go out in the field and actually look at some of them.
Yeah, for
to
sure.
See how it has evolved over the time.
Yep, for sure.
All right.
I'd love to do it.
Tom, thanks for joining us. I appreciate it.
Thanks, Tim.
To learn more about Morel and their systems and solutions, visit morel-group.com. Don't forget to subscribe to Evolution in Controls on whatever platform you use for podcasts or on YouTube for a video version so you can be updated when we release new episodes. Thank you again for joining us today. I'm Tim Wilson, and remember, keep moving.